All right, boys and girls, thank you for joining me once again where, well, James DiNicolantonio continues to be wrong, and I'm a bit disappointed at Rob Kiltz for having this criminally incompetent buffoon on his channel, frankly. But I'll deal with that behind the scenes, or even publicly if I'm invited on Rob's channel to put this nonsense straight. It's not the first time I've put this nonsense straight, and it probably won't be the last because, well, James DiNicolantonio has a real ego problem and can't accept when he's beat and doesn't know when to quit. Anyways, let's deal with it once again, because James says that eating meat is going to cause you to become acidic, or it's going to melt your bones, or some other ridiculous nonsense. Let's see what the actual first principles of science have to say about that. Let's go.
And we'll talk about the acidosis thing too. So we are actually alkaline. Our blood is 7.4 pH. A lot of people...
Yep, and it's tightly controlled there via homeostatic mechanisms. The blood pH changes very little throughout the entire physiological range, even in the case of an exhaustive exercise test to volitional exhaustion, where the blood pH never drops much below 6.8. And the difference between 6.8 and about 7.4 is about 12 parts per 100 million. There is no difference in your pH to speak of your blood throughout the entire range. Okay, so before we even get going, James is completely off the planet here.
People think alkalinity, acidity is...
Also, alkalinity and acidity, they're not inverse things. Acidity is a scale which ranges from 14 to, well, it says it ranges from 14 to 0. It's actually possible to get below 0, but that's for another day. Alkalinity is a different scale of a different property of fluids, which tends to have an effect on the pH, absolutely, but let's not present these things as if they're inverse things. They're not. They're independent, parallel things that do have an effect on each other.
Is foolish. You can't eat an alkaline food. You eat a human, that's like, we're 7.4 pH on blood. We're actually alkaline. And so...
You've said that already, James.
Fresh meat is alkaline. This is what
so what?
I'm trying to get at here. It has bicarbonate.
Yes, which is volatile. So?
Blood has bicarbonate.
Yes, which is volatile. So?
Interstitial fluid has bicarbonate.
Yes, which is volatile. So?
And the bones have millions of milligrams of carbonate.
Right, so there's plenty of capacity there. Good.
Which can form bicarbonate in the body.
Yes, good. Okay, so where's the problem, James? Still looking for it.
So when we used to eat a fresh animal, the pH was 7.4.
Still so what?
It was high in bicarbonate.
Still so what?
It was low in what are called hydronium ions. People
so what?
Call them protons.
You used to until I corrected you on it, James, remember? And I do.
It wasn't acidic. It had a pH of 7.4.
Yes, so what? Still.
By the time 6 hours had passed, the pH is now about 5.5.
So what? What happens when you put something in your stomach, James? It's dissolved, if it's protein and fat, by acidity in the stomach. The acidity of that stomach being tightly regulated within a range that's physiological for stomach juices, gastric juice, thus adjusting the pH of whatever you put into your body to the pH that your stomach wants it to be before it passes it through into your alimentary canal. Homeostasis, James, it's still a thing. The body still protects its function against such insults. What's the problem? Other than a very, very severe ego problem and an inability to admit when you've been bested by a superior intellect who knows more about a given topic than you do. Now, look, James has a remarkable and very impressive publication record. He's very prolific as an author of journal articles in the peer-reviewed literature. Congratulations, James. That's great for your CV. What that does not do is inform us in any way, shape, or form on your actual competence in any given field. And the field that you are wading into here is the field of acid-base homeostasis and calcium homeostasis, as you say, a ramification of that, This is something you do not understand. You do not have command of the basic first tenets, the basic first principles. You do not understand the basic laws of physics, James. I've shown this multiple times in videos already, and yet you continue to espouse this ridiculous, nonsensical, anti-scientific argument as if it enjoys some kind of support. It doesn't, other than in opinion pieces. The actual science does not back you up. But we'll get to that. Let's go.
It's actually more acidic. The bicarbonate is
It's so hot.
gone.
Okay.
And acidity is up. Why is that important?
It's not, James. I've just said why it's not important.
When we eat animal protein, that does lead to an acid load.
No, it does not, James. False. Absolute nonsense. Rubbish. What acid, James? Still. I've asked you this question 100 times, and you've got it wrong every single time you've answered the question, and you haven't even answered the question the same way every time. You keep changing it around, because every time I smash you out of the park, you come back with something equally ridiculous. What acid are you referring to? Acid, by the way, boys and girls, takes the form HA, where H stands for whatever the cation is, and A stands for the anion, whatever that is. Okay? The cation is a hydronium ion, or several hydronium ions if you've got an acid that can split off, so they say, several of these. And the anion is whatever the anion is. Okay? An acid has no physiochemical charge, no electrochemical charge. It's neutral. Okay? So it has no effect on acidity. Isn't that crazy? The only thing that affects acidity as regards an acid are one of two things, or both. The so-called evolution of the ionic form of the acid, the dissociated form of the acid, the H plus and the A minus. So which of those things is a problem when you eat meat, James? Please establish which it is and by what mechanism, according to whom. This will be interesting. Off you go.
I can talk about the two main mechanisms of how this occurs.
Well, you can talk about your theory on that, but you're going to be incorrect again, James. Still.
But when we were eating fresh meat, it wasn't as acidic. It had some bicarbonate.
Yet still, so what? The stomach acidity still sets the effective acidity level of whatever's in there once it's been in there for several seconds, really. What's your point?
The natural waters we consumed always contain some bicarbonate. So bicarbonate is more carnivore, real wild carnivore, than not. And if you look at animals, especially lions in a zoo that just eat muscle meat.
Yes, lions, good. Any argument about human physiology is always made more powerful, James, by a reference to a completely different animal. Obviously. I wish I wasn't so stupid. Because if I wasn't so stupid, I'd understand that making comments about what happens in human physiology on the basis of lions makes perfect sense. Of course it does. My bad.
They develop osteoporosis. So why would we think?
So you feed an animal, which is not a human, a diet which is completely inappropriate, and they get osteoporosis. Okay.
As humans, which we're less carnivorous than lions.
Well, that's not so, James. Earlier in this video, before the point where I started responding to it, James was talking about the nitrogen isotope testing. So he clearly knows it exists, in which case he knows that humans occupy a higher trophic level than lions. So either he's very, very stupid indeed, or he's lying. I wonder which it is. If James ever actually grew a set and agreed to meet with me face-to-face on camera for a live debate about this topic, we'd be able to find out which it is, because I'd ask him all the right questions. That'd be fun for everybody, wouldn't it? Except for James, who would end up looking very, very silly, which is appropriate because James is very, very silly. As regards this topic, that being acid-base homeostasis and calcium homeostasis, as that relates to the eating of meat in humans. Okay?
That we couldn't potentially develop osteoporosis if we're only eating muscle meat.
Yeah, but you said it right there, didn't you, James? Potentially, you said. Okay. Well, so what? Show me that this occurs over a lifetime in humans under decent observation and control. Whoops. We're finished. So is James, as far as his credibility goes in this area. Only he can't see that. He won't see that. His ego will not allow him to understand that as regards this topic, he is not an expert. He does not understand what's going on. He does not have control of basic first principles or laws of physics at his fingertips. He is a boy in short pants, academically, in this specific area of interest. And he needs to pull his head in. Still.
That's the key. It just doesn't have enough calcium, too.
Oh, so rubbish. Muscle meat contains exactly the right amount of calcium for a human. Prove me wrong. With science. Here's a good challenge for you. Science, by the way, James, does not include opinion pieces. Science is experimental, observational, disciplined, and it's under control. It also extends for the tenure to which you want to extrapolate, and no shorter. Good luck finding any studies that can support you in that. There aren't any. Should we move on?
It's acidic, and I can go into how it causes an acid load in the body. But
you can't, though, James, because it does not cause an acid load in the body. I am still waiting for you to name the acid. On one occasion, he said it was sulfuric acid. It was wrong, because sulfuric acid cannot exist at physiological pH. Then he changed it to something else, which was also wrong. It's all covered in videos I've already made about James on my channel. You can go and watch those if you like, boys and girls. They're a rip snorter, laugh-a-minute education fest. Edutainment fest, really. It's awesome stuff. Go and watch those videos after this. You'll love it.
It also doesn't contain enough calcium.
Rubbish. Still does.
So how would we improve our carnivore dietary lifestyle?
By not listening to a single word James DiNicolantonio has to say about the consumption of meat as that relates to calcium balance or acidity in any way, shape, or form, because he does not understand. He's got it completely wrong, and he still needs to pull his head in.
Yeah.
In what would be the proper way to prepare, process, and save your meat for later?
Well, I think it's going to be pretty hard for people to kill an animal themselves and eat meat fresh within the first couple hours, right?
Nope. I live on a farm, James. Did you know that? I bought a farm about 15, 16 months ago, whatever it was. Buy a farm, they said. It'll be awesome. Anyways, that's for another day.
That's like,
but yes, I could actually kill an animal right now if I wanted to and eat it immediately. Actually, if I wanted to. I don't, but I could do that.
Not realistic. So let me give you some tips on how to help this.
And would that make any difference to my acidity? No. Would that make any difference to my calcium balance? No. It wouldn't. Still.
This is what I do.
Let's all do what James does, because James does it. I thought this was going to be about science. My bad.
Simply take a combination of sodium and potassium bicarbonate with each of my animal-based meals.
Why would you do that? Sodium and potassium are, of course, a great thing in the human diet. No argument there. They're electrolytes that are very important. We need an intake of a certain amount of those on a daily basis, either from food or from salts that have already been extracted from somewhere else and put in a container. Here, have some salt. Sure. Bicarbonate, James, though. The thing is, James is going to claim the bicarbonate is the thing that's the ameliorative problem-solving artifact. It's not. Because bicarbonate is volatile. Bicarbonate is a dependent variable in an aqueous biological solution, i.e. you cannot independently set the concentration of bicarbonate by adding or by removing. I should say by attempting to add or remove bicarbonate. It just shows a complete destitution of comprehension of the basics of physics, the physiochemistry involved It shows a destitution of comprehension of basic tenets like Le Chatelier's principle, for example. It shows no understanding of energetics in any way, shape, or form. It's a schoolboy level of comprehension of the relevant physiochemistry of this area of interest. James is not the only one that has these misapprehensions, by the way. There are many well-qualified academics who do not comprehend this area. Absolutely. I'll give you that. Nonetheless, James is the one that's putting his head up above the parapet, claiming that he understands this, despite the fact that he absolutely patently does not. So it's James that's copying the ire. Fair enough? I don't care if you don't think it's fair enough, it still is.
Meals. Now, people say, well, you don't want to alkalinize the stomach.
You can't. There's no way. At least not in a chronic fashion. You can acutely change the pH of your stomach by adding or removing something that would have that effect to your stomach. But what happens is your stomach reacts to that by readjusting the pH back to where it wants it to be within seconds, actually. How does it do that? By pumping ions one way or the other across the stomach lining, if you like, to add or remove ions from that fluid pool, and it's that which adjusts the pH according to the correct, unassailable, and absolutely unchallenged, in fact, model put together in the 1980s by the late Peter Stewart. And it's correct still, whether or not James likes it. It's still both internally and externally correct, whether James likes that or not. And it's still based on first principles of physics. Unlike James's idea, which is not. It's a fantasy, James. I'm sorry. Not sorry. What's next?
That's going to mess it up. It only acutely decreases the acidity by a little bit, and the stomach rebounds within 30 minutes.
Right. Okay. So you've got that right. And it's not 30 minutes. It's much quicker than that, James.
So you're going to fully digest the meat. The reason why you want to consume it with a meal is because the acidity comes when you eat the meat. So if you don't boost bicarbonate and have the bicarbonate there while the hydro.
So what are you suggesting now, James? That a stomach acidity coming up when you eat meat is a bad thing? Despite the fact that homeostatically that's what your body does. With malice aforethought, on purpose. Why would you think your stomach would increase its excretion of those ions into the gastric pool, the stomach fluid, that would cause it to become more acidic in response to meat going in there? Why does that happen, James? Precisely in order to break down the meat and the fat that's with that meat, James. It's supposed to happen. What's your point?
Uranium ions and while bicarbonate is being depleted, you're not getting an optimal hit. So I take about anywhere from 1.3 to 2 grams of sodium/potassium bicarbonate.
Okay, right. The only effect that is going to have in terms of the pH is this, James. Whether it's sodium or potassium bicarbonate, either of those salts will ionize in the stomach fluid pool pretty much immediately on contact within 10 to the minus 6 seconds. Why within that? Well, it's probably almost immediately. We say less than a millionth of a second because that's the quickest we can measure things at this point. Okay? Those two ions behave very differently in the fluid pool. The sodium and the potassium are not volatile. They remain in that fluid pool until they are pumped out of that fluid pool by the stomach lining, if that's what it wants to do. While ever they are in the fluid pool of the stomach, because of their positive electrochemical charge, they will force down the activity of the auto-ionization of the water in the fluid pool. That will cause the effective pH to increase, i.e. the acidity to decrease, working directly in opposition to what the stomach is attempting to do, become more acidic in order to break down the meat and the fat more effectively. Okay? The bicarbonate ion, James, is part of the bicarbonate buffering system which according to Le Chatelier's principle and the basic laws of physics, energetics, etc., is volatile. It will evolve from that fluid according to the local pH of that fluid at that time, and it will be ejected as carbon dioxide gas. So what you're doing is completely nonsensical, and your interpretation of what the ameliorative agent is completely nonsensical. You do not understand the basic physiochemistry involved here. You do not understand basic physics. You are completely out of your depth in this particular field, and you should stop, because what you are saying is irresponsible, misanthropic garbage, James. Still. Doesn't matter how many times you say it, or with what proposed authority you claim when you say it, it is still wrong, false, in fact, irresponsible. Stop it.
With every basically 7 to 10 ounces of my animal foods to offset the acid load.
There is still no fucking acid load, James. Still does not exist. Claiming that it does not make it so. It still doesn't.
Now, some people will say, well, I don't believe in this acid load.
I wonder which people they would be, James. Some people.
Right? Like, and that's a fair question.
It's not a fair question. It's a statement of fact. The acid load that you refer to does not exist, James. It's a basic tenet of physics. Still.
I didn't understand this either until I started researching and publishing.
Until I called you up on it and proved you absolutely, unequivocally to be wrong. And instead of withdrawing and apologizing to me publicly, you double down on your ridiculous nonsense and claim things to be true that are demonstrably untrue. Not good enough, James.
On it. We need to understand what happens.
That's right, I do, and you don't.
So there's really only 2 mechanisms for how eating animal protein leads to an acid load.
But it still doesn't, though, James. So there are no mechanisms by which that occurs. Not one. Let alone 2.
It's the oxidation of cysteine in the liver.
No, it isn't, still.
That's the primary mechanism.
No, it isn't, still.
So some methionine can convert to cysteine,
Mm-hmm.
and then that cysteine can be oxidized in the liver.
Mm-hmm. To what?
To cysteine sulfonic acid.
Right. How much of it? And how does the body deal with that? Because homeostasis is still a thing, James.
Now that produces 1 hydronium ion.
No, it doesn't. Your assumption there, James, your false assumption, is that the way hydronium ions enter a fluid pool is via the dissociation of an acid. That's not how it happens. That's completely at odds with the reality of the universe, according to basic laws of physics, as outlined quite correctly and completely unassailably by the late Peter Stewart in about 1983. Okay? So an acid, sulfuric or otherwise, has no effect on the pH, none at all. Not a jot. Ions absolutely do have an effect on the pH. Yes. Where do they come from? James doesn't know. James doesn't understand. James is laboring under the false idea that the habit of chemists of stoichiometrically balancing equations on the left and right hand side, and chemists falsely applying a law that they propose as a law which isn't a law, actually, i.e. that of the conservation of mass, as a reason for so doing. These are where the problem is. That's why James cannot conceive of the level of incompetence that he's exerting here, or exhibiting here, I should say. That's why James cannot conceive of how it is he is so badly in error. Because he thinks he is working according to known laws of physics. He's not. He's making things up. Well, he doesn't even have the intelligence, actually, to make things up for himself. He is repeating what he has heard from somebody else who also didn't understand it. That's what's going on here. Carry on though, James.
Okay, and that hydronium ion acidifies the cytosol of the cell.
No. The hydronium ion exists within the cytosol of the cell precisely because of the modification of all the so-called constants, the dissociation so-called constants, which occurs according to the conservation of energy, which is a law, at least locally. Not universally, it isn't. That's for another day. That's what's going on here. Nothing to do with some acid spitting off a hydronium ion, which is not what happened still.
Now, throughout this process, there are more things that happen and more hydronium ions form in the mitochondria, but that doesn't acidify the body.
Oh, right. So only the magic ones that are so-called spit off the so-called acids that you propose are being produced in some meaningful amount, which they're not. Only those magic ones are the ones that are causing the pH to change. The other ones, which are exactly identical in every sense, are not having that effect. Good. Okay, I'm glad James is here to sort me out on my stupidity and my lack of understanding.
When you form hydronium ions in the mitochondria can handle that themselves.
Right. Unlike the cells that can't. Only the mitochondria have homeostatic mechanisms, not the cells, not the human organism at large. Only mitochondria. You absolute imbecile, James. How is it possible to be as stupid as you apparently are and have an academic record as apparently impressive as yours? Other than, clearly, you don't have to be the sharpest tool in the shed to get a PhD. Neither do you need to be the sharpest tool in the shed to get 2 peer reviewers to agree to a number of papers that you've written about things, some of which may well be correct, but certainly the stuff you're talking about, acidity, not correct, James. Not remotely correct. Not remotely acceptable in terms of basic tenets of first principles of physics, physiochemistry, all of that. Still. Also, James, it's very, very telling that you have refused repeatedly to come and face me live in person on camera to have a discussion with me about this on multiple occasions. That's very telling, James. Because if you know more than I do about this, if it's very easy to dismiss my arguments to my face, why don't you do that? Make your point. We know why he doesn't do it, don't we, boys and girls? We all know why. Okay?
Can put them through the proton pump. They can add it to NAD. They can add it to FADH. So those protons.
So now James is proposing that chemically binding hydronium ions to anions has a direct effect on the pH. He hasn't even got that correct, because that's not what happens either. Wow.
Which are actually exist as hydronium ions, because there's never a free proton. It's always H3O plus.
Remember who it was that educated you on that, James, and corrected you on that, and you've adopted that. Why don't you allow me to educate you on this whole acid-base area, James, and adopt the appropriate, correct, unassailable position on it? Then your ego would be back in check, except that you would have to thank me, acknowledge me, and apologize to me publicly for your arrogance and your erroneousness hitherto, which obviously your ego won't allow you to do. That's why you won't front up to me. As long as you can continue to pretend that your vacuous, erroneous, nonsensical arguments purporting to dismiss my quite unassailable facts, and I'm not there to correct you on them at the time, as long as you can continue to do that, you feel as though your ego is safe. And I'm just some clown, according to you. Well, if that's the case, come and prove me a clown to my face, you absolute coward. Get your ego under control, son. Right, what's next?
So the hydronium ions that are forming in the cytosol have to be buffered. So
No, they don't have to be anything of the sort. The conservation of energy is one of those basic laws of the universe. The local conservation of energy is one of those laws of the universe which acts automatically, all by itself, with very little help from the organism, to maintain very tight control over the actual pH of any fluid pool within the human body, James. Some fluid pools in the body are allowed to vary more than others, with good reason. The cell cytosol and the blood are two fluids that change very little throughout the entire physiological range, i.e., less than 12 parts per 100 million at all times, right up until the point just immediately before you're going to die. There is no need to buffer anything. It all occurs all by itself, according to Le Chatelier's principle, according to the speciation of the ions that are found universally within the aqueous biological solutions. Okay?
bicarbonate goes into the cell.
Bicarbonate is not a buffer. Bicarbonate is a volatile, dependent variable in terms of its concentration in any fluid pool. It is volatile via the bicarbonate buffering equilibrium system that will not predictably affect the pH, control the pH, buffer the pH. That will not work, that cannot work, that is against the laws of physics, James, still.
And it drops the bicarbonate levels in the blood and in the interstitial fluid in particular.
But the body's able to evolve bicarbonate to replace any thusly removed by evolving that bicarbonate from other places where bicarbonate is part of other molecules where it can be cleaved off that. Furthermore, bicarbonate can be absorbed into the system via carbon dioxide gas, which is a ostensibly unlimited supply of in the atmosphere surrounding the organism. In other words, take in a breath of fresh air, and if your body needs some bicarbonate because of where it is physiochemically, the carbon dioxide will dissolve into the blood and become bicarbonate ions. James. Still.
Acidifies the body.
Rubbish.
It drops the bicarb by about 2 millimolar when you're consuming about 200 grams of protein.
I wonder why that might happen. Well, that would allow the acidity of the gastric juice to increase, the pH to decrease, that is, thus making the breaking down of the meat and fat to the constituents required for absorption by the body much more efficient, according to the evil machinations of the homeostatic mechanism, James. Okay?
Because of this hydronium ion that's being formed in the cytosol. The other part of the equation...
When you're talking in the cytosol, the same rules apply. The cell can import and export various things to itself in the same way the stomach can. The exact requirements for the pH level of cytosol and for stomach fluids is quite different, absolutely. But they're both maintained within a tight physiological range to suit their requirements at that time. Still.
Is the Stewart model of acidosis.
Ah, here we go. The one that James knew nothing about, even its existence, until I educated him to that fact, which he's now going to attempt to take a crack at, despite the fact that it is absolutely unassailable and is based on first principles of physics and has never been effectively challenged by anybody in any meaningful way. Still, he's going to say it's a theory. James, everything's a theory, including our very objective existence. That's a theory too. You cannot prove that you exist. The way to disprove a theory is to show good reason why it is demonstrably false. Nobody has ever done that with the Stewart model. Ever. What's next?
Which is what Bart agreed.
I get a mention. I exist. Great. Given that you're acknowledging that I exist, James, perhaps you should come and face me like a man to deal with your ignorance, your arrogance problem, and your incorrectness with respect to this specific field of endeavor. And I can educate you as to your, well, I can try and educate you, James. The fact of the matter is, I really genuinely, and this is not, I'm not being rude for the sake of it here, but I really genuinely think you lack the intelligence to actually grasp what it is I would say to you on this. I really don't think you have it within you to get a hold of this. Nonetheless, I'm happy to point it out publicly for the edutainment of of my many thousands of viewers and your several. Okay?
He's with me and him debate on all this, but
no, we don't, James. I've invited you to debate me, and you've refused every single time. Writing comments backwards and forwards in text is not a debate. A debate is when you face me like a man and we have a discussion publicly for everyone to see. Which of us gets this and which of us doesn't? Okay?
The other part is the formation of sulfate, which is the
sulfate, yes?
negatively charged anion.
Yes, it is.
Now, when we consume 200 grams of protein, that forms about 3.5 sextillion sulfate anions.
So?
Which forces bicarbonate to go into the cell to maintain.
Nonsense. That's not the mechanism. Why is the sulfate associated with bicarbonate, so-called entering? Look at the physiochemistry of it. Read the Stewart model, James. It will explain it to you. When you increase the concentration of a negatively charged anion in a fluid pool, that necessarily increases the auto-ionization of the water, increases the acidity. The homeostatic mechanism wants the acidity to remain within an acceptable range, and it's the bicarbonate that is used, borrowed, in order to achieve that goal. It's not a stress. It's not a problem. You have an unlimited supply of bicarbonate all around you in the atmosphere in the form of carbon dioxide gas, which can be absorbed into the body at any breath that you take it in. There we go. You also have quite a huge supply of bicarbonate, as you've already outlined, in your body, in the structures of your body already. There's no shortage of bicarbonate. Bicarbonate is not a problem here. The body is simply looking after its homeostasis. It's controlling the pH very, very tightly within the range it wants it to be. So what?
Electroneutrality. So we push these negatively charged sulfate ions out of the liver cell, but we can't do that. The body has to maintain electroneutrality. So
and it does. It's not that the body has to maintain electroneutrality. Electroneutrality, James, is a basic law of physics. It is a case-limited, specific example of the local law of conservation of energy. It happens all by itself. That is the thing that automatically affects the dissociation constants of all the ionic species in the milieu of the body fluids. And you still haven't grasped that.
Bicarb, which is a negative charge, goes into the cell, dropping bicarb even further. Bart agrees with me on that part.
No, I don't agree with you on just about anything, James. At all. You are an imbecile as regards acid-base homeostasis and calcium homeostasis in the human body as a result, so-called, of this so-called acid load, which still does not exist. Load meaning a problem. The context of the word load in this context. A problem somehow. No, it isn't. It isn't a problem. Still.
He doesn't believe in the traditional model of acidosis. But
it's not that I don't believe in it. The traditional model is demonstrably false, James. When something is shown unassailably, demonstrably to be absolutely, unequivocally false, as a scientist, it is your responsibility to reject and spurn that false model. Okay? It's very simple. Stewart did that in about 1983. Catch up, son.
Does agree with me that if you raise and alter the strong ion difference by increasing sulfate, bicarb will go down. So that part.
Yeah, but so what? It's supposed to do that, at least in the very short term, until all of that is rebalanced over several minutes to several hours, depending on what the physiological circumstances are.
He agrees with me on. For some reason, he doesn't believe in the traditional model of acidosis. I don't know.
Because it's wrong, James. It's false, demonstrably, absolutely, unequivocally false. And the fact that you can't conceive of why it's false is exactly the point I was making previously. Ergo, you lack the intelligence to grasp the correct model, it seems. I'm sorry to have to point that out, but that's just the fact.
I don't know why, but that is how literally eating meat acidifies the body.
But it still doesn't. It still doesn't. Because the pH range of all the biological fluids remains within the physiologically acceptable range at all times, right up until the point about a minute or two before your life is going to end. That's what it does. It's not a stress, or it's not a distress. It's not a problem. It's not difficult for the body to achieve. There is no limit, in effect, to the resources that are used to achieve this homeostatic mechanism, James. It is the result of at least 3,800 million fucking years of evolution. Many millions of those years in our speciation having been spent by our species and our immediately predecessing species that weren't quite yet human, eating almost nothing but meat and the associated fat thereof. For goodness sake.
And how does that contribute to cardiovascular disease or other damage to our body?
It doesn't, because it does not occur, Robert. The acidification that James is talking about is a fantasy. It's a ridiculous notion that is not supported by any form of science. This is James's theology. Still.
I would say, first of all, we don't have definitive evidence that it does do that, but we have
Well, he got that right.
good mechanistic evidence from
No, you don't. You don't understand the mechanisms, James. You are completely out of your depth as regards the mechanisms. You do not understand the mechanisms.
Animals, etc. First of all, when you let's take it back to what is becoming acidified. The blood doesn't really acidify that much because it has.
Right, well, there you go. For goodness sake, son. So the body becomes acidified by eating meat, but it doesn't become acidified. Which is it, boy? I'll tell you which it is. The body does not become acidic from eating meat, okay? Your argument is done. We're finished. Why are you still talking?
Buffers. It's a hidden acidosis.
Oh, right. A hidden acidosis. No, James. There is no such thing. Either the body becomes acidic as a result of eating meat, or it doesn't. And you've just given us the answer. You've just admitted it right there. It doesn't. Why? Because it is buffered. Is there a limit to the buffering capacity? Well, not in effect with respect to the amount of challenge that is being applied against that homeostasis, James. To all intents and purposes, the body is perfectly able to maintain its homeostasis under those circumstances, i.e. eating meat. Because that's what it's designed to do. It's what we're made out of, meat, isn't it? Meat and fat. Bit of water, a few electrolytes, a very, very small amount of carbohydrate stored in our body, that carbohydrate being perfectly capable of being manufactured by the body itself. Our dietary requirements are meat and fat. That's what we should eat. Is that going to cause us to dissolve through acidity? No, it's not.
So we have hemoglobin, which is not in the interstitial fluid, and we have albumin, which combine these hydronium ions. And so you look at someone's pH and they look fine.
That's because they are fine because of the exact mechanisms you've just outlined. Still.
Interstitial fluid, lymphatic fluid, does not have those buffers. It will become more acidic.
Except it doesn't to any meaningful level. Remember, the entire range of the blood pH, for example, is 12 parts per 100 million. From the most acidic that it ever gets to the least acidic that it ever gets in a living human being that's about to continue to live and not about to die immediately? Still.
We have the many mechanistic data and human data proving this. Let me
No,
start.
you don't have data proving dick about fuck, James. You're an imbecile who does not understand what he's talking about in this field of endeavor. You're a boy with an ego problem here. Still.
For the highest level of evidence of how we know that.
Oh, we're back to the hierarchy of evidence again, are we? The hierarchy of evidence, which is itself an opinion, and as such, rates itself as right down the bottom of itself, i.e., debunks itself. Good. Well done, James. That's some good sciencing. I wish I knew science as good as you did, James. That way I'd be able to make shit up like you do. And ignore the actual science that really does exist. Perhaps what I would also need to do is get my ego completely out of whack so that I could be as clever as you are. Maybe not. I think I'll stay where I am.
Bone is being broken down.
No, it's not, though. There's no evidence for that whatsoever. You're talking about an effect which you propose is likely to be a problem for a human over a lifespan. Well, show me a study where humans are kept under lock and key, observation and control for a lifetime to support your claim. You and I both know that does not exist. You and I both should know, although you clearly don't seem to know, James, that it's totally inappropriate to extrapolate any finding from any study beyond its tenure. That's a mistake, it's a schoolboy mistake, basically. This is the bit where James is going to start talking about the pseudo-clinical lock-in studies that were done over relatively short periods of time while humans are adapting to a change in their diet at a time during which any amount of strange things can occur that James doesn't understand why they're occurring, and that James will now then go ahead and extrapolate forward as being a problem for a lifespan, even though the evidence is quite clear that they're not. Let's hear it, though.
On a high animal protein diet, because we have an over 1 year metabolic ward carnivore diet called the Bellevue study.
Yes, right. So 1 year. I'm always telling people when they change across to a carnivore diet from a standard diet, several things. Number one, I'm saying don't do that overnight. Make sure you change slowly, glacially over 6 to 8 weeks so that you don't upset your system too much. Give it a chance to adapt to the changes you're making. And secondly, don't expect to get to the end of this process of adaptation for well over a year. So as regards to your 1 year study, James, so what? What do you think that shows? It shows what happened in a small number of people, plus or minus the noise around that signal, in those people under the conditions that they lived at that time. Does it show anything about anybody else? And no. Does it show anything about a period of time longer than the period of time that the Bellevue study extended for? No. You cannot assume that any trend that you can observe over a year will continue over 1 year and 1 day, or 10 years, or 50. You can't do that, James. That's not scientifically appropriate. And you attempting to do that is an absolute knife in your own ribcage, put there by you. It shows your incompetence to correctly apply the disciplines of epistemology of science. It reduces your credibility to zero. Sorry about that, not sorry.
In Vilhjalmur Stephenson and his colleague Anderson.
Right,
Now,
so 2 people. N equals 2. Are we done?
everybody, it is true, they didn't have any apparent issues. They were
Fuck me sideways. Seriously, boys and girls, really? So James is going to tell us that we're going to have a problem over a lifetime using completely inappropriate extrapolation of data beyond its tenure on the basis that over 1 year, 2 people experienced no problems. Okay.
healthy. They didn't develop scurvy, but they were in negative calcium balance
What is that, James? How was that established? Bring that study to me for our face-to-face debate.
the entire time they had calcium balances done.
And was it a straight line relationship over that time, over that year, James? Was it? Spoiler. Nope.
Which everybody glosses over. And it was
Because it's meaningless, James. As a prognostic data set, n equals 2 over a short period of time physiologically, 1 year, which showed a non-linear relationship, time versus so-called calcium loss, which you still haven't told us how that was established, by the way.
was it not just a small calcium balance, it was very significant.
No, it wasn't, James. False. if it was significant, clinically, we would have seen a problem. We didn't. You said that yourself a few seconds ago, remember? But I'm the one glossing over things. Okay.
So Anderson started out with anywhere from 300 to 500 milligrams of negative calcium balance.
Per what period of time, James?
He had 3 months of balance studies done in the metabolic ward.
So 3 months. So not a year, 3 months. Because as soon as you leave the ward, we're done, aren't we? Not under observation and control. No verifiability of that N equals 1 observation. Are we done? I am.
They stayed on the diet for about a year, and
How do you know? Were you there? Was anybody there? That's why you need them locked in a lab, so that you can verify that that occurred.
both came back at month 11 for more balance studies.
All right, so we didn't even test even every month in that 12. There were 3 months, and then a gap, and then a final test. So what happened in that gap, James? Given that it was not measured. So anything that you could say is going to be a guess, an interpolation, which is just as inappropriate as extrapolation, isn't it, son? The answer is yes, by the way. It's the only answer you can give and have any credibility.
And both Stephenson and Anderson were still in negative
So N equals 2.
calcium balance.
Yes, at month 11, they were still in negative balance. According to whom, on the basis of what, and to what degree?
By about 175 to 180.
All right, so it was less after 11 months than it was in the first 3. What does that tell you? If you were to extrapolate that forward, which would still be inappropriate, what would you find? To the rate of calcium loss over 2 years, 5 years, and 10, and then 50. Anyone with any mathematical ability whatsoever, or even the ability to think for themselves, will know the answer to that question, won't they, James? It seems like this is a problem that might, not even a problem, this is an observation that seems to be only for the first year or 2 or 3, whatever. And there might be an excretion of calcium for homeostatic reasons, because your body's not just going to spit out calcium in the urine for the sheer hell of it, is it, James? Because after 3,800 million fucking years of evolution, the human body's pretty good at maintaining its homeostasis. It really knows what it's doing. But anyways, it looks like this calcium leaching that you're talking about slows down over time and would therefore be expected to come to a halt at some point. Also, how much calcium was being taken in? You might be able to tell us during the 3 months that they were in the lab locked in there. What about the 9 months after that where they were not under observation or control? They just said, this is what we did. We all know about respondent data, don't we, James? At least we do if we're scientifically at all competent, which I think we're all getting the idea one of us, James, is, and one of us is not, despite the fact that one of us has a larger publication record than the other one. It's you, James, that has the larger publication record. Well done. Congratulations. Nonetheless, you're an idiot. Your publication record does not mean that you have any grasp of science, clearly. It means you can get some articles that you've written past 2 peer reviewers. I did that too, quite a few times. Not as many as you have, but quite a few times. They're really good. People should read them. I'm the science me, safe and effective. Nobody question the science. That's bigotry and hate speech. I won't have it. We'll shut you down. Anyway, come and talk to me about it face to face, James.
85 milligrams every single day by month 11. So in other words, it doesn't stop.
That's right, but it does slow down. And so if you extrapolate that forward using that curve, it will stop at some point, won't it? I wonder if there are any anecdotes out there of people who have been eating nothing but meat and animal fat to speak of for 40 years. Richard Rodriguez. Oh, there's one. How about Maggie, the rancher from Canada? 68 years of it. Neither one of those are puddles of flesh on the floor because their bones have dissolved, are they, James? Well, we're talking about anecdotal stuff, because anything that happened beyond the 3 months in the lab in the N equals 2 study, the Bellevue study, well, that's anecdotes. Okay, goodness gracious.
Bodies don't adapt to this.
They do, though, James, as evidenced by the slowing down. You absolute imbecile. This is an example of James ignoring objective reality completely, or objective logic, because this is still anecdotal, all of it. The logic of his anecdote requires him to understand that this is a curve of attenuation, an attenuating curve that levels out to 0 at some point. No? Okay.
We still are in negative calcium balance after a year.
Yeah, you said that already, James, and I've already dealt with that many times, including today here. Can we move on?
However, the loss of calcium did drop by about 50% over the year.
That's right. So what would happen over the next year? If we assume, which is inappropriate, but let's assume the same relationship occurs over the next year and it halves again and again and again At some point, it basically gets to zero, doesn't it? With respect to it being a meaningful loss. And again, do we have people falling on the floor in puddles who eat nothing but meat and fat for decades? No, we don't. Okay, what's next?
It started at about 350
Yes, we heard you the first time.
milligram loss every day, dropped down to about 175.
Right, there you go. So there's the logic that dismisses your argument. And you've just shown a straight line there with your hand. Is that appropriate? No, it's going to be curvilinear.
Milligram loss. Now, I added up everything. I added up the entire
Oh, I'm glad you added up everything, James. That makes all the difference.
loss for the 4 months of balance studies in Anderson. It was
So 4 months, yes. So what was it 3 or 4 though? By the way, James, because you said 3 previously. Is it 3 or is it 4? I'm glad you've got a real handle on this research and what it says and what was done by whom for how long.
34 grams of calcium lost out of the body.
Yes,
Now,
in 3 or 4 months. Okay, yeah.
how do I know that
3 or 4 grams. Are we done? If we weren't already done, are we done now?
most of that has to come from structural bone?
Who told you that? According to whom? On the basis of what, James?
Because we only have 4 to 10 grams in the exchangeable pool that could even come from anywhere else. So if we assume that the
So how much calcium could you consume on a daily basis that could be added to that pool if it was in ionic form when you consumed it?
entire exchangeable pool of bone calcium got depleted, and that
Well, then you'd die because you require calcium for a number of biological processes, including the contraction of muscular tissue, including the cardiac tissue. So if there's no calcium in your body, well, your heart can't beat. Sorry about that.
at most that's 10 grams. 34 minus 10, 24 grams essentially had to come from structural bone. There's no other place it could really be pulled
So
from.
you're saying 24 grams. I must have misheard you before. Okay, yep, fine. So what?
If you drop blood calcium, you die. If
Yes,
you drop tissue calcium, you die.
yes. That's why it comes out of the bone, James, in small amounts for a few months while you're adapting to a diet that you've changed to suddenly without the appropriate period of sliding slowly from one thing to another. And that slows down over that few months. And as it seems, if you interpolate out to the 11-month test, it seems that that continues to reduce, meaning that it should continue curvilinearly, if you're going to apply that logic, ongoingly, such that this is a short-term issue, which then your body can then redress. You still haven't, though, actually given us any idea of why you think the calcium is being leached out, if that's what you think is going on. Because you're saying it's due to acidity. It's not. Still, why is it happening? Give us a mechanism. Tell us why this is happening, James. But of course, the most important thing is, okay, even if we don't understand why it's happening, which I suspect James doesn't, is it important over a lifespan? Well, the answer is apparently not, despite James's hypothetical idea that it is. His nonsensical, ridiculous, anti-scientific view that it's likely to be a problem.
At the absolute most, you could lose maybe 1 to 2 grams outside of the exchangeable bone pool. Regardless, 22 grams had to have come from structural bone.
Yep, so what?
And
22 grams? How much were they taking in? What was the actual effective loss?
every metabolic balance ward study that has ever looked at a carnivore or high animal protein diet has shown bone breakdown markers increasing. And
yes, over what period of time, James? Because we expect that when you change somebody's diet inappropriately quickly. The homeostatic mechanisms kick in and cause homeostasis to be maintained in the face of the physiological challenge of the inappropriately quickly changed diet, after which a period of time goes by and the body gets used to what's now going on and it stops that problem. And then it would be logical, wouldn't it, James, to assert that the body then repairs any damage, however small that may have been in terms of the bone mineral density, by then redepositing calcium thereafter. Don't you think? No, seriously, do you not think, James, at all, ever, for yourself, that is? Seems not.
and see telepeptides, bone formation markers decreasing called osteocalcin. So we know from the bone turnover markers, the physiological loss of calcium that can only be explained through structural loss.
Yes, short term in a very small amount, which is then redressed and redressed. Yes, so what?
In my opinion, it's been proven that the calcium that is lost in the urine, everybody.
Yeah, but your opinion is facile, anti-scientific in its very construction, lacking severely in the application of basic common sense, let alone actual logical progressions. The thing about opinions, James, is that they're just like anal orifices. Almost everybody has one, and it's full of shit. Your opinion. Okay, well, your opinion is daft, absolutely ridiculous, and it's not based in science. So can we move on now?
He knows that high protein diets lead to more calcium in the urine. Everyone used to always think that that only has to be due to an increase in absorption of calcium. But the problem is that's not true. When we look at the balance studies, most of it is...
Again, you're focused on short-term responses to acute challenges to homeostasis imposed suddenly without a lead-up period inappropriately. And you are then extrapolating that out to suggest that that is going to remain a problem for any given human being for their entire lifespan beyond that point, which is total nonsense. Absolute, utter nonsense. It shows absolutely no grasp whatsoever of the understanding of the human capacity for adaptation to various challenging situations. It's called the homeostatic mechanism. It's still a thing. It still works very well. Goodness sake. When does this finish? There's still quite a bit left.
Actually coming from bone.
So what's our fix to this?
Well, there's no problem to fix, Rob. There is nothing to fix. A bit of prevention, is worth a lot of cure. And the prevention for a lot of this issue with the calcium excretion in the short term at the front end of changing your diet across, that can be attenuated by changing your diet slowly over several weeks, not overnight, so that the balancing off and then redressing of any loss that was a short-term issue is easier for the body to achieve. That's all. Nothing else. Just do that. Job's a good one. What's next?
Bicarb, either eating...
Bicarb is not the answer still, James. Bicarb is still a volatile anion, which is still subject to Le Chatelier's principle and still is not able to set its own concentration by being added or by being removed from an aqueous biological solution, still, for goodness sake. And there is still no mechanism that you have outlined linking bicarbonate to calcium in any way, shape, or form. Please provide a mechanism by which you think this will ameliorate the calcium loss.
If you are okay with eating some low oxalate plant foods, potatoes is...
That's the last thing you should do. That is contraindicated, misanthropic, stupid advice from a buffoon who is not qualified in human nutrition. This boy's PhD is in pharmacology.
What I do. Okay, and I think we should be eating potatoes with meat for several reasons, because...
Well, then you're an idiot. We should not be doing any such thing.
This randomized controlled studies show...
There are no randomized control studies which are appropriately randomized or appropriately controlled to show us, James, anything at all. Still, the body of literature existing on human health outcomes as that relates to any aspect of the diet whatsoever is pustulous excremental garbage from top to bottom. It's rubbish. Still.
That when you eat food...
What we need to do to inform our practice, James, is apply an appropriate understanding of basic first principles, including physiochemistry, anatomy, physiology, biochemistry, first principles. No peer-reviewed study, so-called, shows us dick about fuck.
Meals that contain more red meat, DNA adducts do increase in the colon. Because you have the heme iron, you have free iron ions from red meat. It's not like red meat is bad per se, but we need to understand that it can still oxidize arachidonic acid, linoleic acid, etc. And so the fiber...
It's almost as if the body would recognize that and produce a bunch of antioxidants endogenously that deal with that problem. All right, that's right. It does.
Potatoes has been shown to decrease DNA adduct formation in the colon.
No, it hasn't been shown to do any such thing, James. Bring that study to our debate and I'll tear it to bits for you within minutes. It's rubbish. Absolute incompetent rubbish that you're espousing there, not science.
So I balance my meat with some potatoes. It's still not enough, though. You typically need 2 to 3.
So using the terms balance and meat and potatoes is completely inappropriate. That's not balance. That's just stupidity.
Times the volume of low oxalate plant foods to offset the acidosis of animal
You
food.
still don't need to offset the acidosis because there still fucking isn't any. Hidden acidosis, he said. What an absolute buffoon. What a clown. Hidden acidosis. Either the acidosis is an observable phenomenon or it's absent, James. Sorry about that, just the logic thing again. I'm kind of stuck in this logical framework. It's a real limitation to my life.
foods. So I just take about 1 to 2
It stops me from making shit up because I feel like it.
grams of sodium/potassium bicarbonate without all my animal-based meals, and I know that I'm offsetting the acid load.
You don't know dick about fuck, James, regarding acid-base balance or the homeostasis of anything, really, as regards to this whole idea of meat and calcium. You don't know anything. You are an imbecile. You do not have control of first principles here. You do not understand basic physics. You are incapable of grasping the Stewart model because you are too stupid. Sorry. Not sorry. Okay, so we're done with the acid-base calcium issue. Completely done. James is wrong, demonstrably wrong. James lacks the scientific acumen in this field of endeavor to be remotely competent in what he's talking about. He has shown a destitution of comprehension of actual acceptable standards of epistemology and science from top to bottom. He's made a fool of himself once again, and Rob, you've let him do it without challenging it. A bit disappointing. Not nearly as disappointing as you inviting this clown on your channel at all with any other intent but to actually debate the boy and prove him wrong, completely wrong, irretrievably wrong. I've done it time and time again on my own videos. James won't actually front up for it, though, because he is a pussy. Anyways, that's what's happening today here in Pimbatia, the independent sovereign nation. Join me next time when someone else will be wrong on the interwebs, because it doesn't look like slowing down, doesn't it? See you then.